Greetings, everybody. So what you see here is a problem that somebody sent me on my MyMathLab, and I'll answer it for you. What you can see, though, is the question and the correct answer. And I'll address it like this. I have one page that contains some notes, some things that we need to know before we start working the problem. And then the next page, which you see here, shows you how to work it. And I try not to leave anything out. Okay? So I'll go through this in a lot of detail, but with math, there's always more I can show. By the time you get to the class that you're in, there's a lot of stuff that you've already seen, and so much of it can come into play in this question or anything else. Okay, so here goes. Before I do this, I have a few notes on some things that we need to know. First of all, to find the integral here of this sort of thing, the rule that is operative is this one. Okay, so here's what this says. It says the indefinite integral of x to the n power. Now in that case, x is the variable and n is some fixed known number that is the power. And the answer to that is that you add 1 to the power, that's the n plus 1, and you divide by that very same number, n plus 1. And then you add plus c, c is the constant of integration. All right, so here's an example of that. Suppose you had x to the 1/2 power. So again, x is the variable, and then 1/2 is the power. It's a fixed known number. So what does the rule say that I do? I add 1 to the power, so that makes it 1/2 plus 1, and I divide by that very same number, 1/2 plus 1. It turns out 1/2 plus 1 is 3/2, or 3/2. So I get 3/2 there, plus c. And then whenever you divide by a fraction, that will be the very same thing as multiplying by the reciprocal. So here I'm dividing by 3/2, but that's the very same thing as multiplying by 2/3, and that's what you see here in my answer. Okay, so this is the rule that is ultimately the operative rule in this problem that you see here. Now, the difference is, notice when I told you about this rule, I said, well, x is the variable. So when we do calculus, we have variables. We have these things that can change. X is our typical symbol for that, but it could be any other letter of the alphabet. And I see in this case the variable is t. That doesn't change how any of the rules apply. It's just that we have a different label for the variable, t instead of x. All right, now here's the other rules that we need to know. We'll need to know some rules of exponents. Now, you learn about exponents when you learn algebra, and there are lots of rules for exponents. I'm not going to talk about all of them. I'm just going to talk about the rules for exponents that we need to know. So here's the first one. It says when you multiply like things, you add their exponent. So for example, if I take x to the power a times the same thing, x, to another power b, I get x to the power a plus b. So when you multiply like things, you add the exponents. Okay. An example of that might be this. Suppose I had t to the second power times t to the 1/2 power. Look what I did there. I have t instead of x. It doesn't matter as long as those bases are the same. So x and t. What do? If you multiply like things, you add the exponents together. So that's going to be t to the power 2 plus 1/2, which turns out to be 5/2, or 5/2. So that is going to come into play when we solve that problem up there. And then this will also, this second rule that I have here for exponents states the equivalence between roots and fractional exponents. Okay, it says the a root of x to the b power could be seen as the same thing as x to the power b over a. So, for example, I'm going to connect some dots here. See how this rule right here that I ultimately need to use requires there be a power? It says x to the n power. But I noticed that in my question, this thing I'm given is the 7th root of t to the 4th power. So, this rule does not directly apply to that. I need to see that I have t to a power. Okay, so notice here I say, okay, well, here's the equivalence between roots and powers. The a root of x to the b power is the same thing as x to the singular power b over a. So by that pattern, by that rule, if I have the 7th root of t to the 4th power, then that would be t to the power 4 over 7. Okay. To give you another example of that, what about the square root of t? Well, the square root is the 2nd root, so there's a 2 right there. And if I just have t, I guess the power would have to be 1. So the square root of t is the 2nd root of t to the 1st power. Writing that with a singular exponent by this rule would be t to the 1/2 power. Okay, so those are the rules I need to know at the very least to do this one. Now, here we go. So here I've copied down the problem that I have. Now, I see this and I want to see that I get my variable t to a singular power. So I can use this rule. So first thing, let's take these roots and write them as powers. That seems like a reasonable first step. So the square root of t is t to the 1/2 power. The 7th root of t to the 4th power is t to the 4 over 7 power. That's from this rule right here. Okay. All right. Next thing is I need to just see one singular term of t to one singular power. You know, this rule says you have x to the n power, x being your variable. I need to see that I have t and that there's a definite power there. So can I combine these? See how that says t times t to the 1/2? Is there any way that we can put that together into one thing? Well, remember this rule? It says when we multiply like things, we add the exponents. We could use that. So t to the 1st power times t to the 1/2 power is t to a power 1 plus 1/2. Multiply like things, add the exponents. All right, so now we're getting somewhere. At this point, I could use this rule that I pointed out to you from the beginning. Okay. Now, one other thing I do now, there are lots of rules. Okay. The further you go in math, there are more rules to know and keep track of as you're doing something. So what I'll do next is I'll apply some rules that I didn't mention, but I'll talk about real quick right here for integrals. Like for this thing which is called an indefinite integral, I can factor out constant coefficients like a 10 and a 6. And I can split it up across addition or subtraction. Okay? So that's what I've done here. I've taken out the 10, I've taken out the 6, I split up the minus, and so what I have is 10 times the indefinite integral of t to the 3 over 2 power minus 6 times the indefinite integral of t to the 4 over 7. Now it's at this point when I can use this rule directly. All right, so what does that rule say to do? It says, well, you see what the power is, 3 over 2 in this case, 4 over 7 in that case. I add 1 to the power, and I divide by that same number. Carry down the 10, carry down the minus, carry down the 6. Add the plus c, the constant of integration. Okay. Now, 3 over 2 plus 1, that's 5 over 2. 4 over 7 plus 1, that's 11 over 7. And then, in a final step, remember over here I said, well, what does it mean to divide by a fraction? So I see right there I'm dividing by 5 over 2. And right here I'm dividing by the fraction, 11 over 7. So what does it mean when you divide by a fraction? Well, that'd be the very same thing as multiplying by the reciprocal. So what I'm really doing here is multiplying by 2/5. Not dividing by 5 over 2. I'd rather see it as I'm multiplying by 2/5. And here, I don't want to see it as I'm dividing by 11 over 7. I want to see it as I'm multiplying by 7 over 11. So I've got the 10. I'll write 10 over 1 times 2/5. I got the 6. I'll write 6 over 1 times 7 over 11. Now, putting that all together, I would get, how do you multiply fractions? You multiply straight across. 10 times 2 is 20 over 1 times 5 is 5. Okay, so 20 over 5. All right. Hold on a second. So, oh, look at me. I made a mistake. Nobody's perfect. See how I wrote an 8 there? Okay, I have to come clean. 20 over 5 is 4. That should be a 4. I don't know why I wrote an 8, but like I said, nobody's perfect. So that's 4t to the 5 over 2 power. All right. 4t 5 over 2 power. And then 6 times 7 is 42 over 1 times 11 is 11. And then times t to the 11 over 7. Okay, so I made that mistake, but it happens. All right, so what my final answer would be, 4t to the 5 over 2 power. I know you see an 8 there, but I told you why it's a 4. Minus 42 over 11t to the 11 over 7 plus c. So at that point, we're done. That's our final answer. It wouldn't make sense to simplify any further. There's nothing else we can do that would make this any simpler than you see it right there. And that's the answer that we have given with the question. Okay, now, so you might see it as there's a lot going on there. And I prefaced this with there's lots of rules that are in play here. I talked about some of the important ones over here. But, beyond that, you would have to reach out to me if you weren't so sure about the fractions. Like, what do I do with 4 over 7 plus 1? How is that 11 over 7? Or I mentioned a little bit about dividing by fractions and multiplying, but I didn't go into a lot of review about that. So that's another thing that if you were stuck on this problem, you could reach out to me, tell me what you don't understand, and I can help you from there.